Hello guys, welcome back to my channel. I do LeetCode problems and other tech related stuff. So we are on a coding spree, problem solving spree, okay? Today problem is called linked list cycle. Given head of a linked list, determine if the linked list has a cycle in it. There's a cycle in linked list if there is some node, it can be reached again by continuous following the next pointer. The description is quite confusing for me, but I understand from because I already solved it, right? So don't keep in your mind this position or whatever this thing, okay? It just doesn't really matter. So there's a linked list and we need to find if there's a circle in the linked list. If the tail point back to some nodes and then it goes around like loop endlessly, okay? That's the game basically. 3, 2, 0, 4. Then 4 points back, 4 dot next points back to 2, and then it goes again and again and again, so it doesn't end. That's a cycle linked list, okay? So we need to find if there's a cycle and then return true or false, okay? We have two methods for this, but they have a condition here. It says, can you solve this in order of one constant memory? Okay, so we have two solutions. One is not constant memory, and another one is more optimized, which is constant memory. The first method, we're gonna use hash set. So we're gonna check for the unique elements, hash set integer. The first method we're gonna use is called hash set. We're gonna add these nodes into the hash set because hash set only has like a unique element. It only contains unique elements. So if we found that again, we're gonna check in hash set, and then if we found that already exists in hash set, that means there's a cycle. We just return, true, false, whatever. So hash set of list node. Okay. We don't use the value of the node itself because the value can be duplicated, because there could be node where there are like same values but they are not. That doesn't necessarily means they are cycle. Okay, they could have the same value but they could be pointing at different nodes, if you know what I mean. So we're gonna use node instead. Hash set, we're gonna name it visited equals new hash set. Okay, then we're just gonna run a while loop while head is not equal to null. So we're gonna traverse through every element, every node. We're gonna check if visited dot contains head. If it does contain head, that means there's a cycle. So return true, right? Otherwise, we just add it. Just add into the visited dot add head. Okay, we just add the element and we just move the counter. Head equals head dot next. And if we don't found it after traversing through, that means there's no cycle in the linked list. So return false. Let's run this quickly. Visit it. True, accept it, and then see it's 4 milliseconds the runtime, you can see here, and we are at here. Our runtime is not that great, so now we can optimize this solution and we're gonna use a constant space. Time complexity is order of n because we're gonna traverse through the list n times, and the space will be constant like they asked us to do here. Okay, so this function name is called turtle hair fast and slow pointer basically. Okay, so list node slow equals head, list node fast equals head as well. So we're gonna start both of them at head, and then we're gonna check while fast is not equal to null and fast dot next is not equal to null. So why do we have to check these conditions, right? Fast is not equal to null when fast dot next already checked for the next one that it's not null, right? The reason is sometimes we could have an element. Why do we need to check fast is not equal to null when we can just check fast dot next is not equal to null, right? Because sometime the element itself, let's say the head itself, could be null. So in that case, we will run into null pointer exception. That's why we use fast is not equal to null and fast dot next is not equal to null, so that we can check the next one. Okay, so we're gonna move fast and slow. The slow one will move one node at a time. Fast node will traverse two nodes at a time. And while they traverse, let's say while they traverse here, Okay, if there's a cycle, they're gonna meet at some point. But if there's no cycle, it will come out of the loop because there's a null in the end, they will come out of the loop, right? But if there is cycle, the fast will eventually catch up to the slow, and then they will meet at a point. That means there's a cycle, so we can just return true. Okay, we can check. Let's do slow equals slow dot next, fast equals fast dot next. Okay, and then we check if slow equals fast. Again, we're not checking slow.val or fast.val, we're checking the node themselves, checking the location themselves, because value could be duplicated. And then there could be same values but different nodes. So we don't compare the values, we compare the node themselves, the location of the node themselves, okay? So if they are same, that means there is a cycle, return true. Otherwise, return false. Otherwise, that means they came out because the last element could be null, that's why they came out of the loop, and then it's false. Okay. You can see it works the same, very clean code, very optimized. You can submit this. Then you can see it's 0 millisecond, way faster than the previous one. Previous one was 4 millisecond. Okay. So this one is also constant space complexity. So because we don't take any extra space, 2 nodes, so it's still constant. And then runtime is order of n, linear. So very optimized. So thank you very much, guys. If you have any question, let me know in the comment section. And I'll really appreciate if you subscribe or anything like that. Okay, really helpful for me. Happy coding. See ya.